All right, so this is our video to cover quiz 7, the problems of quiz 7. So I'll go over each problem. If you still have questions, you can email me, and I can either try to answer your questions by email, or if necessary, we can schedule a one-on-one Zoom appointment to address any clarifications. All right, so this first quiz, this quiz covers sections 11.1 and 11.2. So 11.1 was just finding limits of sequences. So our first problem was this: the limit of 5 to the nth power divided by 5 to the nth power minus 4 to the nth power. One of our important principles for finding limits of these kinds of quotients is you look at the top and the bottom and you figure out what is the most powerful term that appears. So in this case, we're dealing with exponential expressions, and 5 is bigger than 4, so 5 to the n is the most powerful part. So once you figure that out, then you divide the top and the bottom by that most powerful term. So I'm going to divide the top and bottom by 5 to the n. I'm going. On the top, we'll just get 1. On the bottom, we'll get 5 to the n divided by 5 to the n is 1, minus 4 to the n divided by 5 to the n. That's 4 over 5 to the n. And so then you look at that, and as n approaches infinity, the only place that n appears now is as an exponent on this fraction. 4/5 is less than 1, so the bigger the exponent gets, the smaller that fraction gets. So this here, that little piece approaches 0, so my answer will be 1 divided by 1 minus 0, which is 1. So the sequence, the limit of the sequence is 1. All right, so next problem, it's a different sequence. Involving factorials. So now we're looking at 2n factorial divided by 2n minus 1 factorial. All right, so the way you divide factorials, the way you simplify a quotient of factorials is you look at the fraction and figure out which one has the larger factorial. In this case, that's the top. And then you think, okay, what extra factors does the top have that the bottom doesn't have? Well, if I started writing out the factorial on top, I'd write 2n. The next number down would be 2n minus 1. The next number down, I'd keep going. But I have 2n minus 1 factorial from that point on. So I have 2n times 2n minus 1 times everything after that. And so at that point, I recognize, well, that's exactly what I have at the bottom, 2n minus 1 factorial. So you take that bigger factorial and you just start writing out its factors until you get to the other factorial that you're trying to cancel. And so once you do that, then these 2n minus 1 factorials cancel. I'm left with just limit of 2n as n approaches infinity. And that's going to grow to infinity when n is infinity. Right? So that's problem 1 about sequences. Problem 2 is about determining whether each of the given series is convergent or divergent. And when it's convergent, in this case, we want to find its value. All right, so I've got 3 of them here. N equals 0 to infinity. 8 times 7/5 to the n. All right, so first thing is, this is geometric because the sequence that we're adding up is basically an exponential function. It's got a number raised to the nth power. So we need to figure out what is the ratio r, and I want to be careful with how I say it. R is the number you multiply by each time you increase n by 1. So when the power is just n, r is the base. Because every time I increase n by 1, I'm multiplying by another 7/5. So in this case, r is 7 over 5. And then the relevant question is that big or small? Is it bigger than 1 or smaller than 1? Well, its absolute value. Its absolute value is 7/5. So this is already positive. That's bigger than 1. So that tells us divergent. Okay, so that series is divergent. If it's divergent, it doesn't have a value. So there's nothing else I have to say about that. The second one is the summation of 5 divided by 4 to the n. This is again geometric because we have an exponential expression, and that's all that's going on. So it's geometric. The ratio r. Well, what more do we get every time we increase n by 1? Well, I keep getting more 4's in the denominator. So my ratio is 1/4. Because there's no n on the 5. There's just an n on the 4, and that's in the denominator. All right. So that's bigger than 1. So this is convergent. Sorry, it's less than 1. Less than 1. 1/4 is less than 1. So it's convergent. And for a convergent geometric series, we can answer the question, what is its value? So this equals then, I'm going to erase this, but our formula, our so-called formula, is the first term, or the initial term, the first term divided by 1 minus r. So r is 1/4. And then the first term is whatever we get when we plug in our starting n value. So our smallest n value, which is 1, that's going to be 5 divided by 4 to the 1 power. So we've got 5/4 on top, divided by 1 minus a fourth is 3/4. When I divide, the fourths are going to cancel and give me 5/3. So what that's telling us is, if I add up this sequence, the more terms I add, so the more n values I use and I add up all those terms, the total is going to approach 5/3. All right. One more. Summation of 3n squared over n squared plus 8n plus 1, where n goes from 0 to infinity. All right, so this one, this problem came from 11.2, and at that point we didn't have a bunch of different convergence tests yet. This is not geometric. So it's not an exponential expression. It's a rational expression. And at that point, we didn't really have many ways of evaluating these things or determining what they do. The only tools we had were geometric series. We had a little bit of stuff like telescoping series, but that's not this. At least it sure doesn't look like a telescoping series. Or the divergence test. So we look at this, and we look at the limit of this sequence. And without going through all the work again, we've got a rational expression with n squared on the top and the bottom, so the same degree. So the limit's the quotient of the leading coefficients, 3 divided by 1, which is 3, of course. And that's all we need to do, because the divergence test tells us if the thing we're adding up, the expression we're adding up, doesn't approach 0, so 3 is not 0 here, then there is no way this sum can converge. So this is divergent by the divergence test. Okay. So the divergence test, the main idea of that divergence test is if you can look at that expression and quickly see that it doesn't approach zero, it approaches something other than zero, then that tells you the series has to be divergent. You don't have to do anything else. You don't have to use some fancier test. All right, so that's it for this quiz. Again, if you have more questions or need extra clarification, send me an email and we'll figure out how to talk about it more. But that's it.